Welcome to Study Loop.
Okay, so we have a 25-foot chain that has a weight of 30 pounds, and it is suspended between 2 points at the same elevation. Those 2 points are point A and point B in blue. We're also given that the sag, which is H, is equal to 10 feet. So because the chain is 25 feet, that's our variable SAB. So our variable S, which is half of the chain that runs from this point here to point B, is equal to 12.5. So we need to find the distance between the supports, and then we also need to find the maximum tension in the chain. So we know a couple of things. We know that Y is equal to H plus C, and C is some point that we do not know yet that is below the lowest point within the chain. So Y is equal to H plus C. We also know that Y squared minus S squared is equal to C squared. So because we know H and because we know S, between these two equations, we can now solve for Y and C. So Y is equal to 10 plus C, because the sag is 10 feet. We plug equation 1 into equation 2, and we find that 10 plus C squared minus 12.5 squared, which is S, is equal to C squared, which shows us that C is equal to 2.8 feet. So now using C, we utilize the equation S is equal to C times hyperbolic sine of x over c, which, if we go back to our diagram, we find that x is half of the total length between the 2 points. So plugging in for the equation, plugging in what we know, we find that 12.5 is equal to 2.8 times hyperbolic sine of x, which is what we were looking for, over c, which is 2.8. So this shows us that x is equal to 6.2 meters. Now, going back up here, we're trying to find the distance between A and B, which is L. L is equal to 2x. So the horizontal distance, L, is equal to 12.4 meters. And that is the horizontal distance. Now we need to find the maximum tension. So our maximum tension equation is equal to our unit weight per length times the square root of c squared plus s squared. So now in order to find the unit length, we have to take 30 pounds, which is the weight of the total chain, and divide it by 25 feet, which is the total length of the chain. So we find that W, excuse me, I'm going to make this clear. So we find that W is actually equal to 1.2 pounds per foot. And because we have C and S, which we solved for above, we plug this in, and we find that the maximum tension is equal to 1.2 times the square root of 2.8 squared plus 12.5 squared, which gives us 15.38 pounds. That is equal to the maximum tension in the chain.